That's what I like. It's my favorite. I kind of know that. Yeah, about 60.
Okay, I don't know if I showed you this or not. We're on page 95-ish. I don't know if I showed you this or not, but I'm going to show it to you now. On your graphing calculator, it can solve systems of equations. Let's take out our graphing calculators and I'll show you how.
Is that the poli-sci thing?
It is along those exact same lines. It's the same kind of a thing, only this is solving systems of equations. It's the same app. That does not look focused to me. That still does not look focused to me. Okay. So it's under the apps, and it is indeed PolySimul 2. And the one that we're going to use is the simultaneous equation solver. 2 equations, 2 unknowns, next. And you fill in a matrix for the system. Now, the problem for this particular problem is that it's not written in the correct form. So if you put the 30x out here in front, it'll be negative 30x. And if you put the 150 out front here, it's negative 150x. So then when we go to fill it in, we would put in negative 30, enter, and then we could use 1 since there's no coefficient for the y, enter, 12,000, enter, negative 150, enter, 1, enter, 0. And when we solve, it tells us that we have 100 phones. Oh, you can't see that. 100 phones, 15,000 buckaroos. Laura, did you get how to do it on yours?
No.
Okay, let's do it again then. Now, if you're using your phone app, you gotta, you've got to use a different process. Oops, not Fox Sports, Kevin. So I have that graphing calculator on my computer, and I would go to matrix, and you have to go through the matrix form, clear. So for those folks, you want to do it a different way, because the one that's on your phone does not have PolySimul root finder. Okay, here we go. So let's go back to the main screen where we want to get started. Second function, apps. Oops, not second function, apps. Apps. Scroll down to where it says PolySimul 2. Does anybody not have PolySimul 2 on their calculator? You have an older version, probably. You got it, ladies, back in the back table there? Marlene, do you have a graphing calculator? Jess, do you have a graphing calculator? Okay.
On my phone, I have an app.
Okay. All right. Enter. It says press any key to continue. Go to simultaneous equation solver. and click enter. 2 equations, 2 unknowns. It doesn't matter whether it comes out decimals, fractions, don't care. Down here in this corner, you see the button next. That lines up with your graph button on your calculator. Hit that. And then you see a 2x3 matrix. Fill in the values. Now, if you notice, I had to move the 30 over to this side because it always goes X, Y, answer. X, Y, answer. So I had to put the negative 30 first. 1, since this is 1 CX, and it's 12,000. Negative 150. 1. And there's nothing left on this side if you move the 150 to the other side. And then click the solve button, which is also graph. And it tells you 115,000. Now, on your calculator, Lauren, it's a little bit different. Did you get it?
No, not really.
Okay. Here's the problem. If negative 30x, this is just 1y.
Okay.
And then this is 12,000. Enter. Now go to the next row. Negative 150. 1y. And then the last answer is 0. Yep, 1. That's right. And then, oh, you're good. And then 0. Enter. And now click solve. There you go.
Thank you.
You're welcome. You guys getting it? Eric? Sam? Page 95. What I need you guys to do is to answer these questions. Let's look at question 2. One of the IQ phones production manager recommends that they just make a few and sell a few phones, maybe 10 or 20. Why? Well, it's so much work. Phones, and then it's just such a pain. So I think we shouldn't make very many of them. How would his business strategy affect the company's profits? Does everybody agree the less you make, the less your profit is? Okay. Number 3 says an accountant recommends making and selling many phones, 200 or 300. If we sell 200 or 300 phones, we will get lots of profit. Question number 3 says, how does that affect the company's profits? The more you make, at some point, the more you're going to start making profit, right? A marketing manager cautions the company president not to be too greedy, warns her that they may not be able to sell all the phones they make. Well, that's a good point. The market manager decides to graph both the total production or costs and the revenue costs on the same set of axes, and this is what she got. A, B, C, D, do all of it up to letter G, and when we get there, stop. While you guys do that, I'm going to take attendance. So I was watching the news this morning, and they said, now they're gearing up for the 2020 presidential election. I was like, no, they aren't. I'm done with ads. I want to start a rule that you can only say ads about yourself. Or if you say something about your opponent, it has to be something good. I really like my opponent's bicycle policy.
not be slightly.
Yeah, go on.
What's that, Marlena?
They'd be like, they'd say that, and then they'd be like, but mine may or may not be slightly better.
Nick's here. Mike.
Yep.
Marlena. Gavin is absent. Janae, Felicia, Nicole, Eric. Whose bag is that there?
I'm here. Not Eric's.
Okay. Phil,
Yeah.
Grant,
Here.
Connor, Paige. I don't know what's up with Paige. Eric, Laura, Madeline, Sarah. Jesse, Lauren, Jake, and Sam. Anybody need more time, or do you have them? I hear a lot of talking going on, so I don't know if you guys are still working on it, or are you done? Did you get them?
No.
You're working on them? Okay. Know what you're doing, Jake?
Not really.
Well, that first question says, which line represents the cost and which one represents the revenue? You can tell by the slope, right? But you could also tell by the intercept.
Yeah.
Which one had an intercept? Yep. But which one of the two equations, revenue or cost?
Cost.
Cost. So that's the cost axis, and it's also not as steep as the revenue because you're going to gain a lot more revenue. So label them. B. Marketing manager did not label or even draw the horizontal axis. So what would that be?
Phone fee.
Yep. And the vertical axis is amount of dollars, right? Part C. What does that represent?
Equilibrium.
That's where the number of or the amount of revenue equals
Cost.
the amount of cost. Do you have them, Madeline?
Yeah, I got 3 done. I feel like that's more than what I normally do.
Well, and so kick back and relax. I'm like exceeding my expectations. I don't know about yours, Kevin, but I'm like, I got her honed in. It's probably what happens with the Cleveland Browns. They say, you know what, we scored a touchdown. Good for us. Okay, so are you on letter D? No, I'm talking to Madeline.
I am, yeah.
What does 100 mean? 100 what? Very good. And if you make 100 phones for Y, it's $15,000. Very good. Now, in your book, do you have an F? Because I don't in mine. I just go from E to G. Do you have an F?
No, I don't know how to.
I think they made an error. Okay, so let's go to G. Everybody ready? Are you guys ready for G?
Yeah, I'm ready.
Here we go. Let's start at the end. If IQ Phone makes and sells exactly blank smartphones, the company will. So there is one time when it's exactly what? If they make exactly 100 phones, they will. That's the words that we use in economics, right? Break even point. So if they sell less than 100, they will. If they sell more than 100 phones, they will make money. Everybody good with that? Okay. We found a point that satisfied both equations. That is the solution to the equation. They say, let's take that next puppy and graph it, which you see there. And the solution to that system of equations is 0.11.69. Do you see an advantage of graphing a system of equations to help you solve it? Did you really solve it? All you did is you graphed it, right? I mean, it kind of solved itself, okay? That's what happens with kids. If you think you have too many kids, just go and let them play in the street. No, I'm just kidding. I love my children. That was so mean, Kevin. Actually, it was really mean when you think about all those kids that died in Chippewa Falls. They were in the ditch even. They were like not close to the road.
I like how his buddy thought the best idea would be to wrestle the wheel from him while they're going down the road at 70 miles an hour.
The other part that I thought was kind of interesting was, well, at least I wasn't huffing as bad as my passenger. I'm like, yeah, that's... At least I didn't steal as much money from the bank as the other people stole from the... I just am not feeling it on that kind of a thing. Anyway. All right. Number of solutions. That's what we're going to be talking about next. Because it's kind of like when I was teaching chemistry and I thought, oh, this would be so cool. I'll just mix any two chemicals together and I'll get something cool happening. I was like, man alive, I can mix a lot of different chemicals and I don't get any results. There are 3 cases that happen in 2 equations. On page 99, let's do something just a little bit different, and let's say S of t equals 65t. S of t equals 5 plus 65t. And instead of using lowercase, or instead of using numbers down here for the subscripts, fill them in for question 1, which is vehicle 1, the car or the van. So don't use a number down there, use a letter. Okay, let's read through the story there just to make sure we know what the story says. The story says, a car and a van are driving on a highway at a constant speed of 65 miles per hour. The van is at mile marker 0. At the same time, the car is at mile marker 5. Question number 1. How do you know this is a linear situation? It's a word, a magic word. Very good. And you missed out. You know, you snooze, you lose. I don't know what else to say. Couple kids came to our Halloween candy distribution center, and they came twice, and Sunny's like, you were just here. We were. Can we have some more candy? So anyway, you snooze, sometimes you don't lose. Sometimes you still win. So what are you going to put? S sub what is the 65? S sub V is 65. S sub C is 65 plus 5. Okay, so do number 2. Fill in that chart. Go. Everybody ready? What'd you get for the 3 van positions? All right. 30. That's that is supposed to be a 2. So this should be 37.5. Okay. 0, 32.565. What did you get for the car? 5, 37.570. What did you get for a difference?
All 5s.
All 5s. Next page. On this graph, just a few weeks ago, I was teaching this and somebody said, Kevin, I believe I see a mistake with this graph. They are indeed 5 apart at every spot. Do you see the mistake they made? Let's correct it. Because what was supposed to have happened was they got the 0, 0 right, correct? But at half an hour, the van was at 32.5 and the car was at 37.5. So it should be moved up about 2.5 miles an hour. And then at the end, the van was at the lower dot. The car was, at the upper dot, the car was 5 miles an hour ahead of it. So their lines, while they are always 5 apart, they don't have the correct slope. So correct those. This is crucial. I'm going to zoom in on the graph. Here is the car. Here is the van. What does that, like it said, what do the lengths of the short vertical lines represent? In miles, right? Everybody agree this is the shift in distance or the number of miles. Now you could tell it was miles because, over here on the side, what does it say? Number of miles. Is there another way that we could have talked about those two lines and, the car and the van? What else could have we said? They are blank minutes apart, right? They are blank minutes apart. So the one car passes this point at a certain time, and then the other car doesn't pass it until this much later. In this case, which is bigger? The number of miles? Oh, I didn't say what this is. What is the length of that purple line? Number of
hours.
Or in this, does it say hours? Okay.
Is that right?
I forgot if it was hours or minutes. So, would you agree it's going to be a very, very, very small number of hours? In fact, we'd probably be best measuring it in minutes apart. Is the number of minutes more or less than 5, which is the number of miles? How far apart they are? That's a good question, Kevin. Thank you for asking me. How far does the car go in an hour? 65 miles, right? How many minutes does the car go in an hour? 60 minutes, which is bigger, 60 or 65? So the number of miles is slightly bigger. We know this is 5 miles, but this is not quite 5 minutes. So but I'm going to say less than 5 minutes. Page 100. Do, be, 4, and 5. Everybody ready? Or do you need some more time?
You said we had to do 5 too?
3, 4, and 5. They did it on the graph. So if you look at their graph,
Are the points the solutions?
the place where they cross, where those two lines cross, is the solution. Did you see a problem?
Yeah.
What's the problem?
The lines don't cross.
So if the lines don't cross,
There's not a solution.
there is not a solution. Very good. Are they ever at the same place at the same time?
No.
No. Okay. So turn your notes sideways and let's go through the 3 possibilities. The first possibility is there is no solution. We're going to do that one first, and our example is S sub V is 65t, S sub C is 65t plus 5. The key to no solution. Oh, we should graph it too. But we can put the key there. The key to no solution, if you see the equations, is they have the same slope, but a different intercept. So MV equals MC, the slope of the van equals the slope of the car, but BV does not equal BC. What does that mean? The y-intercept of the does not equal. Everybody good? And then, of course, this is how one of our stellar students figured it out that there was no solution. The graph was parallel lines, right? Everybody good with that? So that's the first case. Page 101. The second case. Suppose that the car started at mile marker 5, just like before, but was traveling at 60 miles an hour instead of 65. Let's explore that one and see what we get. Do all the way down to E. Go. Oops, did I go too far? There we go. Did you see your score now, Jess?
Yeah.
Okay. You know what you're doing there, Felicia?
Yeah.
Oh, okay. I know you're reading. That was obvious to me. I meant, did you know what the math is?
Yeah.
Okay. So you can use your S sub V, right? Did that change?
No.
No. So S sub V equals, I'm on letter A.
Yeah.
Okay. S sub V equals 65T. That one didn't change. There was no plus for the, oh, that is a T. I'm sorry. That's a plus. Okay. S sub C,
So this is
you tell me. Very good. Yep, because it started at mile marker 5.
Okay. Can you just graph on the calculator?
Yes, you may.
Calculate decimals.
Now, the nice thing is, if you're doing it in Desmos, if you click on it, it will automatically go to the, or give you the coordinates of the solution. If you're doing it on your graphing calculator, it sometimes gives you kind of a hinky result. I think what they mean for, or what did you guys have for part B? Describe what happens to the position of the two between 0 and 1 hour. They get, is that what everybody had? They get closer together?
For what?
For part B. When you do the graph, as they go from 0 hours to 1 hour, the lines get closer and closer together. That's what they mean, I think. You know what you're doing there, Madeline? You got it
Yeah.
figured out?
Kind of.
I mean, I'm talking about the graphing thing.
Yeah.
Get it, graph?
Well, I forgot to put S equals in there.
You don't need to do...
It didn't graph.
Okay, well, you can do... Try S parentheses T equals 65T.
Oh my gosh, I'm sorry, it's so small.
Come on, you need a bigger phone.
Yeah. She laughed at me. See the biscuits last night. I tried to hold the breath.
Okay, go back one space, and you might not have hit the close parentheses right.
Is this one?
Mm.
This is the fourth one.
Oh, just go forward. You don't need to. Just go forward. There you go. Equals. There you go.
Oh, yeah. Got it. Thank you.
Yep.
And it grabbed.
It didn't graph?
It did.
Okay.
Oh my goodness.
You know what I should do? I should do C of T and V of T. There we go.
Wait, are they like the same thing or something?
Instead of S of T, I made them C of T for the car and V of T for the van.
Oh, I can't see it. Yeah, what is it?
So they cross for 1 hour.
So on my graph, I changed it so now it's dynamic. And you can see as they go along, they get closer together. So let's go to our, what is the slope and vertical intercept of each equation? 60 goes with 5, right? 60 is the slope, 5 is the intercept. 65 goes with 0, right? Will they ever be at the same place at the same time? Yes. So how many solutions does that equation have? Okay, so let's go in our notes to one solution. And the example that we have is the speed, I'm going to do V of t for the van, was 65t. S of t, oh no, it's not, it's C. C of t, that's for the car, was 60t plus 5. The key to I'm going to write it out. Solution is What do you think? Well, let's look back at the previous one. The key to no solution is that the slopes were the same, but the intercepts were not the same. What's the key here? Slopes are different. Good. M of the van does not equal M of the C. So you should be able to quickly determine whether two equations have the same slope or not, if they're written in the intercept slope form. Now I'm going to show you. Let's go back in our notes to that day that we were doing. Oops. I can't because I never actually did the notes there. Let's see here. Oops, I know how to do it. Word. Okay, so that one day that we were doing the notes and we got to nope, that was the this is the one that I was going to why did that not work? This is the one I was going to send you, Madeline. The forms of the linear equations.
And I forgot to email you.
That's okay. The forms of the linear equations, if you see it like this, obviously you just take, if these two numbers aren't the same, then they have a different slope. This is kind of a cool way to do the slope on these kind. First of all, remember this is the standard form. So on these kind, in the standard form, the slope is the x-coordinate, or coefficient, over the y coefficient. So the slope is 3/5, but change the sign, so positive 3/5. So if you see two equations written in the standard form, you can easily tell whether they have the same slope or not. Like, I'll show you. So in this case, we would have had something like 3a plus 4b equals 7. 3a plus 4b equals 9. How do we know the slopes are the same? Because these things match. Okay? So in this case, how do we know? Oh, let's do the graph first. So how do you tell from a graph that there is one solution? Now you may say the lines cross. Do you remember this one from yesterday? When we were graphing this one yesterday? Did the lines cross? No. But if you were going to search for where the lines cross, which way would you go? Towards the upper right, correct? You would go farther forward and farther up. Why? Because they're getting closer together. So we say there is a solution because the lines cross, but just on our paper, they don't have to cross. They just have to have a different slope. Okay, so we could say graph crosses or will cross. That might not be a bad way to do it. And then if we were going to do the 5a plus 6b equals 12. 5a plus any number of b except 6 will make it work. 1,384. Okay? It's something other than 6. It's easy to come up with two lines that don't have the same slope. Got it? Part 7. Go. Oops. So if they are in the same spot, different lanes, what is the slope of the car compared to the slope of the van? They're going down the road at the same speed. Starts with S and ends with AIM.
They're the same.
That's very good. How about their intercepts?
Same.
They're the same intercepts also. Same slope, same intercept.
No, we just did that for no solution.
That was the same slope, different intercepts.
For one solution, does it matter what the intercept is, or does
No, that's why I said that the key is different slopes. Intercept does not matter. Will the car and the van ever be at the same mile marker at the same time? Yeah. Every single one of them, right? Lots of times. An infinite number of times.
Check out these notes.
What is the difference? $25 worth of markers.
Yeah. Just for this cat.
What? You're spending a lot of money on this class.
Yeah, I tried to pass it.
What will be the difference in position between the two vehicles the whole time? It reminds me of when I was taking the kids shopping. They were afraid of everything because they were always right next to me, and I had to kind of walk like this because the kids were, Dad, Dad. So yeah, they still talk about how they. What is the distance between the two? None, right? The difference will be 0. What will you see if you plot both equations on the same graph?
One line.
One line. In general, how are the slope and the intercept related to the number of solutions? So let's go through it. Our last case. Infinite solutions. Example, v of t is, let's make it 60t plus 8. Because they didn't give us a specific one. C of t is, what did we just say has to be true? So it has to be 60t plus 8. Now, Madeline touched on, hey, I thought we just did that. key to infinite solutions is m sub v is m sub c. Hey, I thought we just had that one. Yes, we did. And b sub v is b sub c. So when we graph them, we get the red line and the green line are the exact same. And in fact, it looks to be black because red plus green makes black. So the thing is, sometimes they will kind of disguise it. Like, for instance, they might say something like v of t is 2t plus 8 over 2, and c of t is t plus 4. So you see how they disguised it that time? They pretended like it was a fraction. They'll do that to you. Or in cases where they have them written in the standard form, they might say something like 5a plus 6b is 12. 10a plus 12b is... Very good. 24. One more thing before we go. It's in lesson we'll just write it at the bottom. Mathematicians are enthralled by their use of vocabulary. We say these two equations are inconsistent and independent. We say these two equations are consistent and independent. We say these two equations are consistent and dependent. Okay, so I'll give you the definitions of the words. Consistent means what you say matches up with what you do. Okay, they cross, or they're the exact same thing. Inconsistent means you never match up with what you say. Independent means that when you write them as a system of equations, you're going to be able to write two different equations. Dependent means when you write the solution, you might sometimes have to go, the equations are A and 3A plus 5, something like that. You can't get a solution as an ordered pair. You have to say it as a equation. All right, we'll take our break. When we come back, we'll be doing C.
Is it possible for you to just print that note sheet out?
The what?
Want to email me?
Oh,
Is it
let's
possible
see.
you just print it?
Let's see here. File.
Maybe.
Oh, I got to see which page. I'm going to print this page. File. Print.
Maybe.
Page. Let's see. Print current page. 201. Should print. We'll see.
I hope so.
Oh, it says it's offline. Can you hit the power button there on the front? Down. There you go. No. Is that there? Yeah, it's down there someplace. There it is.
These are all his bad. Oh, now it's shutting down.
That's not good.
Probably because I pressed it twice.
Orange. This is gonna be. Oh, I'll buy it.
The maximum waiting time is 2 minutes for shutdown.
Oh, okay, yes.
Sorry about that.
2. Green. Red.
What happened?
Shutting down. I pressed it twice. What it printed? I don't know.
Neither do I.
Oh, yes, okay. So actually, no, I'm just going on a call plus a bone, and that's you will understand the whole response. Oh, that's cool.
That's so good. That's so good.
I'm trying to make one. We could do it also, but it was really silent.
Please do not move this pin. Oh, that is so tempting.
Oh, there's another one on the other side of the room. Yeah, where was it?
Why did they do
That one might say you can move.
Maybe it's an experiment. Like some.
To see if we actually will.
that? Kevin, I think you should.
Is it bad luck? Like, what if there's like an out on
What if there's money on the inside?
Put it this way, I don't think it's enough money to make moving the pin worth it because it's a very small piece of paper.
Well, there's another one on that side. So you could just do the one on that side, and then if anything, just put it right back up where it is. It's not like this.
I'm sure there's someone.
Yeah, I would.
I was
I noticed it.
I can't even reach it, so that's why I put it. Yeah. Well, I have Tuesdays. I have class. I don't know. Wednesday, Thursday, Friday. I have class. Oh, is that good? I'm gonna try to get
Seats. They start driving down the road. Get a little too close to the edge. The steering wheel just snaps a little bit. Left. Oh, it's got
But it's too long.
Yeah.
This is nice because my 8 a.m. class and I think we're going to do 2 days a week.
Yeah. So I was like,
Is everybody back?
nope. Control line on the interstate going to work. I just keep going. There's people in the car starts slowing down. All right, it's not the tires are probably
Not bad.
It's weird though. It's a half man. And I look at it, I start laughing. It's got paddle shifters on it. I'm like, really? Subaru Outback with paddle shifters.
Figure that out. The very fun. Try to schedule
We used to fall asleep though. For my WRS, I have pretty much fall into it. Yeah. Outback.
If they give me this stuff to study.
I'm gonna research.
One time I took my hands off the screen. Flashed on the screen.
Wait, for final?
For like this year, since we have that's
I would like
Cars. It was really handy too because I was backing up in the parking lot here. You know, you fly by.
Yeah.
35 miles an hour. I start backing up, and I don't even have to be looking at it. We're into the camera even. The car will start alarming and flashing on the mirrors.
Yeah, I don't even know.
She's just in a while.
It'll actually be directly behind you.
Just like
Okay,
Although I want to pay for it.
page. I don't know what page this is. 103, 104. So we've had a number of different ways to solve equations, and what's interesting to me, and I'll ask you guys the question because I've asked it every semester. When you see two equations, raise your hand if you first go to polysimal 2. Raise your hand if you first go to Desmos. Raise your hand if you first try to solve it with paper and pencil. Okay? Raise your hand if I don't have an opinion. I mean, there's got to be the rest of you that did not vote. Lauren, what were you thinking?
I'm not gonna lie with you.
I was not paying attention. Okay.
This is the winner's table.
That. Okay. Can you guys wake each other up occasionally just so that you can pay attention a little bit? All right. Yeah, and you know, it is true that people use different forms of technology all the time. But the one that amazes me is that you've been so conditioned to thinking, well, if I use something else to help me solve it, it will be wrong. Okay? How many people have PhotoMath on their phone? Is it useful?
Depending.
Not necessarily for this class, but sometimes there are some questions that it's useful for. I tried to use it and it didn't work. Anybody not know what PhotoMath is? That's how I'll show you the video.
You can't really use it for this class, so that's probably why I'm failing.
Oh, I wonder if you have to do the. Let's try it this way. Play. Where's view animated instructions? PhotoMath. Let's just looking for the video. Let's try this one, see if this one is it.
Get the new LG V40 ThinQ at Sprint for only $20 per month. Regular price $40 a month. That's a
Learning any new subject can be challenging. For many students, that subject is math. Fortunately, PhotoMath is here to help. PhotoMath is a new app that not only solves complex math equations, but teaches you how to solve them yourself. It uses your phone's camera to scan the math equation. Within seconds, it spits out the answer. Tap the answer bar to reveal the step-by-step instructions on how to get the solution. Not only does PhotoMath tell you the answer, it shows its work as well. This week, PhotoMath released an update that recognizes handwriting. Previously, the app was only able to read printed text. We experimented with several people's handwriting, and PhotoMath picked it right up. The only problem I came across was with division bars. PhotoMath had difficulty delineating the order of operations. This was simply remedied by embolding the lines. But if all else fails, PhotoMath has included a keyboard option for you to manually edit or type any equation that...
No, that's like that other one that you guys use. What's that one
The update
called?
also brings a new math
Mathway
system, PhotoMath Plus, that solves problems like a human would, and walks users through how to solve the problem themselves with a colorful and useful step-by-step guide. The system seems to address the tension between having an app do your homework versus having an app that helps you learn. This new service could also end up being a helpful tool for parents who want to help check if homework is right and navigate their way through incorrect answers. The PhotoMath Plus service is free through November and will be a paid subscription after that.
Oh!
These new features are available for iOS now and will be coming to Android by the end of the month.
So I guess they're going to start making money off you guys using PhotoMath. I didn't realize that. All right. The point that I wanted to make about this is, if it is a question that's easy enough for anything to do the work for you, let it do the work for you. I can tell by looking at this system of equations that it's not going to come out evenly. What tells me that? Well, that's part of it. But the other part is, look at that first slope. 1,741. How many times does 1,741 come in contact with 50? About every 35,000 numbers. We're going to have to go a long way before we find too many solutions that will come out evenly. The chance of it being just one number, like a whole number, is going to be very, very, very small. How long would it take you to estimate a solution using technology? What they say is that, you can do it much quicker by hand. Okay, that's possible. I don't think I could. But here's what we're going to learn today is the substitution method. 7C substitution. Now, one of the things that we had before is, if you recall, we had the $12,000 plus, were those phones $30 to make? I can't remember. $30 times the number of phones. And we had that equal to $150 times the number of phones. So if you can have the two equations be equal to each other, that's the first way to solve them. But sometimes that doesn't work. And the one that we're doing right now is an example of when that does not work. Y equals 1741 x. Okay? And y equals negative 25x plus 90. Actually, it does work this time, doesn't it? Because we have y the same in both cases. So what would we write? 1741x equals negative 25x plus 90. So we would have to add 25x to both sides. And we get 1766. Oh, it's close to when our country was founded. Is 90. And so x is 90 over 1766. Correct? Substitute that back into here. Y will be 1741 times 90 divided by 1766. I am almost positive that is not a whole number. 1741 times 90. Divided by 1766 is 88.25, or 725. About 89. Y is about 89. So our ordered pair, 90 divided by 1766, will be 0.05, comma, 89 will be our solution. Page 104. So use substitution when a letter is solved for and it's easy to substitute in. Let's look at this example that they have. 2a plus 6b equals negative 2. Then it says a is 4 minus b. So now I'm going to redo that first equation. 2. Instead of writing A, I wrote 4 minus B. Plus 6B equals negative 2. What is 2 multiplied out into that? You get 8 minus 2b plus 6b equals negative 2. Combine these two, what do you get? 4b. Move the 8 over here. No, it's positive 8 on this side, so it's negative 8 on that side. Negative 10. So B is negative 10 fourths, or 2.5 negative. Then substitute that back into the other equation. 4 minus negative 2.5 is what? 6.5. So A is 6.5. So our answer is 6.5, comma, negative 2.5 in parentheses. Page 104, do 4, 5. Do them together so that you can see how you're going to do number 4 and 5. You know what you're going to do there, Gavin?
No.
Well, do you like that fraction part? So why don't you put brackets around the fraction and then double it? Okay, and so multiply by 2. Put a 2 out front. So we're going to multiply everything by 2. What's a half times 2? So y. So write it down here. Y. What's a half times negative 2? I'm sorry, 2 times negative 2. So minus 4x equals, that's just a 1, right? Y minus 4x is 1. Now you've got something that you can rewrite, correct? So write y equals, so put the 4x on the other side. What do you get? Y equals,
This divided by itself.
no, y equals 4x plus 1.
So I moved to 2x.
Okay.
Now substitute that into the first equation. Instead of writing y in that first equation, you would write 4x plus this.
So you didn't get one.
4x plus 1. We're in the first equation, so 4x plus 4x plus 1.
Okay, I'll ask him what I did wrong. So
See, instead of writing y, we're going to write this y equals, what does it say it equals? What does it say it equals? 3. Okay, now what do you get when you add these two together? 8x. And then move the 1 to the other side. So positive 1 on this side, it'll be negative 1 on the other side. So negative 1 plus 3 is 2. So 8x is 2. So get the x all alone. X is 2/8, which is how much? So x is 0.25. Now, how do you find y then? Multiply that by 4.
Okay.
0.25 times 4 plus 1,
Oh, another way to do it.
right? 0.25 times 4 plus 1 is,
1/2 of y.
so x is 0.25, y
And
is
then
2.
1/2.
Did you get it, Nicole?
4.
You don't know.
So we multiply
completely
this
honest.
stuff to get y.
If I'm completely honest, I wasn't paying attention. No, that was somebody else at a different table.
That was me.
Thank you.
Oh yeah, because it's a denominator, so I can't. It has a numerator and denominator. So
Oh, you did them equal to each other. And what did you get for an answer? This is as far as you got? Okay, when I get to this part right here, I always move the smaller number, or the smaller variable to the other side. So negative 4x on this side is positive 4x on that side, right? Yep. So you get 8x, and then move the 1 that's next to the 8x to the other side, so it's going to be subtract.
Holy shit. Okay.
Which means x is
You see how I did that though? And then I brought it over and then
0.25, right? Okay, so if x is 0.25, substitute that into one of your two equations, doesn't matter which one. You know what you did wrong? Can't figure it out.
Yes and no.
No, they aren't. The reason why you think they're parallel is at some point, let's see here, you multiplied everything by 1?
At 2.
By 2? Which,
So
we'll just wait. What was this right here? What were you trying to do
I
here?
factored out the 1/2 of the y minus 2x.
And what did you end up with?
I got y equals 4x plus 1.
Y minus 4x equals 1. Okay, y equals 4x plus 1. Got it. And the other one is y equals negative 4x plus 3.
Okay.
Okay. So this is why y'all can divide it instead of multiplying by 2. Because I thought that I can't go out by division, but since it's already a fraction, we can do that, right?
No, you can't. Whenever I see a fraction, they call it clearing the denominator. And the way you clear the denominator is by multiply everything by all of the denominators.
So it'd be multiplied by 2.
So what would that equation become there? Y minus, no, 2 times 2 is
4.
x equals 1. Got it? Lauren, how are you doing? Y minus 4x equals 1. Yeah, and that's right here.
Yeah, but are you supposed to double that one too?
No, you don't have to double that one in order to make them the same. You only have to. Okay, I'm going to go through some of the rules that are confusing us. The original, I'm just going to deal with the second equation for right now. 1/2 y minus 2x equals 1/2. I said multiply everything by 2. Why? Because you guys don't like working with fractions. So let's change it so that it's not fractions. Now here's the part that some people were confused. What allows me to multiply the whole thing by 2? Well, do you remember when we were just working a few minutes ago and I said sometimes they disguise equations to make them look like they're different when they're really the same, and we just doubled everything? That's exactly what I'm doing here. What's the advantage of doubling it? Well, it gets rid of the fraction because 2 times 1/2 is 2 times negative 2 is, and then 2 times 1/2 is 1. Now, here's something else that confused somebody is they said, well, if I multiply that equation by 2, don't I have to multiply the other equation by 2? Well, no, because all we need to do is to get these two equations so that they're written differently. At this point, somebody said, well, Kevin, those two equations are parallel because they saw the y and they saw the 4x and they ignored What did they ignore? The negative sign. Do you see that? So not only are these equations going to be they're going to cross, they're actually going to be perpendicular to each other. Okay, now you could, either equation you could substitute for y, and in fact what Lauren did is she said, well, I'll just make both of them substituted for y, so I'll write this one as y equals 4x plus 1, and I'll write this one as y equals negative 4x plus 3, and then I'll just make them equal to each other. 4x plus 1 equals negative 4x plus 3. And once again, somebody said, doesn't that make them parallel to each other? Because they saw the 4x on one side and the negative 4x on the other side? Remember what I told you to do in this case? Always move the smaller one, and negatives are always smaller, to the larger one side, and we get 8x Am I not on an outside wall?
I'm so confused.
Did you hear that sound?
Oh, yeah.
8x plus 1 equals 3. Subtract 1 from each side. 8x equals 2. X equals 2/8 or 0.25. Which I can substitute into this equation right here. 4 times 0.25 plus 1 is 1. So my answer is 0.25, comma 1. Question. I heard somebody talking.
Oh yeah, it was me. I just keep getting it wrong because I keep forgetting. So I forgot that 4x and negative 4x were like terms. So instead of, I divided negative 4x. So
Very
4x.
common things to do. The hard part is remembering what they did to the numbers in order to know what you do to the numbers. Here's what I think she's talking about. How do I know when I have an equation 4x plus 1 equals negative 4x plus 3, how do I know to add and subtract rather than multiply and divide? The rule is to combine the like terms before you divide. Think about it this way. We know that our order of operations is lem das. The order of solution is sad mel. So do the additions and subtractions before you do divisions and multiplications. That'll help you. Number 5, let's look at the problem. One possible way of solving this system is given. The first equation is solve for x. X equals 3 plus y. Everybody agree that's what they did? They just moved the y to the other side. Then they substituted in. Instead of writing x, they wrote 3 plus 2y. So 2y minus 2 times 3 plus y equals 4. So they substituted in. Then they took the 2 times the 3 and got negative 6. 2 times the y and got negative 2y. Everybody agree? That's 4. But what's 2y minus 2y? No y's, right? So what do you have left on this side? Negative 6 equals 4. Is the algebra correct? Yes. When does negative 6 equal 4?
Never.
Page. Let's page back in our notes here. And let's write this down. when you solve this kind of system, solving will result in something like 6, or it was negative 6 equals 4. So you'll be working along, you'll be solving your stuff, and all of a sudden you get negative 6 equals 4. That's the problem that you run into with that kind of system. Would you agree negative 6 never equals 4? Would you agree there is no solution? Okay, so that's what they're trying to show you is how you end up with that as one of your possibilities. Page 105, let's look at that math. So here's what they said to do. Let's take this first equation and get the y all alone. So y equals 3 minus 2x. Everybody agree? Then they said, well, since y is that, why don't we substitute that into the second equation? 6x plus 3 times 3 minus 3 times 2x is 9. Or in other words, 6x plus 3 times 3 is 9. 3 times negative 2x is negative 6x is 9. 9 equals 9. When is the algebra correct? For what values will the last statement 9 equals 9 be true? It's always true, right? So any value of x will have a solution. So in our notes, we would write over here, nine equals 9. Okay? How do we know we have an infinite number of solutions? Because it's going to be something foolish like that. Well, what is going to be true if there's one solution? If there's one solution, we're going to have a variable equal to something, like 4 or 9. Okay? We aren't going to have a number equal to a number. We're going to have a variable equal to a number. I am not going to leave number 4 alone without showing you how to have confidence solving that equation. Four x plus y equals 3. The second one is a half. I'll agree with that. But they switched up the variables to kind of confuse you. Always write the x first. Negative 2x plus 1/2 y equals 1/2. Everybody ready? You got that? So we can go to polysimul 2, and we can do simultaneous equation solver. We can do 4, enter 1, enter 3, negative 2, enter. Now you can either do 1 divided by 2, or you could do 0.5. It doesn't matter. Enter, and then 1 divided by 2, enter, solve, and it tells you the solution is 1/4 and 2. Or You got that? Everybody figured out how to do that on their calculator? Or you can go to Desmos. Enter the equations exactly they're given. 4x plus y equals 3. 1/2 y minus 2x equals 1/2. I do not mind if you use Desmos or if you use your graphing calculator or whatever you use to solve these systems and equations. Because nobody in real life is going to care how you do it, okay? Just like when you type a paper. If I, as your teacher, said, you have to turn off your spell checker and your grammar checker on your word processor to do this paper. Yeah, Janae's gave me the look. Yeah, like, for real, Kevin, that is not going to happen, buddy. Okay? So when I do, I can just click on the solution, and it tells me the solution is 0.25, comma 2. I absolutely need you to have confidence in this, in solving systems of equations. So figure out one of the many ways that I've showed you to get them right. Okay? Don't crucify yourself for saying, well, I can't do it that way, Kevin. They didn't ask you to do it that way. They want you to know how to, but they don't require you to know how to. Page 107. Elimination. How do you eliminate a variable? Well, you look here, you have 2y minus 3x equals 4. Three y plus 3x equals 1. So you know how I showed you that you should use substitution when a letter is solved for and when it's easy to solve? You should use elimination when the variables has the same coefficient but opposite sign. Now it said elimination by addition. So let's add these two equations together. What do we get? Well, 2y plus 3y is 5y. Negative 3x plus 3x. You should be getting good at this, Jake, right? Fool me once, I will see that it's, if they're on the same side, they will eliminate. But if they were on opposite sides, that's where we had the problem. 5y equals 5. So in other words, y is 1. Sometimes we want to eliminate, or we want to use elimination, and the coefficients don't match. Notice we got y to figure out y by eliminating the x's. Now to figure out x, we have to eliminate the y's. And here's an easy way to do it. Multiply the top equation by negative 3 and the bottom equation by positive 2. So that these two numbers equal negative 6. These two numbers equal positive 6. So the first equation becomes, now remember, you got to do it times each part. So you get negative 6y plus 9x. You see why it's plus 9? Because you got negative 3 times negative 3 equals negative 12. Negative 3 times 4 is negative 12. 6x plus 6y equals 2. Right? Add those two equations together. These two are going to cancel out, and you're left with 15y equals negative 10. Divide both sides by 15. Y equals negative 2/3. Did I make a mistake here? Oh, this is supposed to be x here. Sorry about that. X is negative 2/3. All right. So that's elimination. Number 4. How do you think what they said to do was, well, let's just multiply the first equation by negative 3. That way we can eliminate the x's. So they multiplied the first equation by negative 3, and they got negative 3x minus 3y is negative 9. So they added those two equations together, and they got negative 3x minus 3y plus negative 3x plus 3y equals negative 9 minus 2. Or minus 3, I'm sorry. So the x's and the y's crossed each other out, and they ended up with 0 is negative 12. Which situation are we in? Which one? No solution, right? You end up with something that isn't true. No solution. Let's look at this one. They multiplied the first equation by negative 2 to get negative 6y plus 4x is negative 8. They added them together. Negative 6 canceled the positive 6. Positive 4x canceled the negative 4x. Negative 8 canceled the positive 8. And they got down to 0 equals 0. What kind of a situation do they have? Infinite number of solutions. Okay. Next, page 111. We're going to get started on this. I'm going to give you a study that talks about heart rate and different things. Here's your study. Here's your study. And here's your study. Find out from your study what heart rate has to do with age. And I'm going to send you guys one in Chippewa too. I mean in Menominee too. Wait, my drive. Classroom.
Well, I mean, I had this 2 hours left. Are you doing too? So what's it that? I just like can't do it. I remember you used to be ready for me. I'll be an asshole. But it's important. My English teacher, that likes the shoes to be on, rather than the shoes to be on. He could be an asshole. Yeah. I was like, in the rules is like this.
I think it'll be coming. Did you guys find it in your study?
Yeah.
It's fine. You haven't even looked at it yet. Tell me you found it. Yes, you're going to have to go with one group or another. So you're talking about patients that receive beta blockers. Okay. In this study, there's going to be an equation that has heart rate and an age in a formula. Okay, so just scan it.
No, I just don't feel like it's like 5% average.
This is the same one that's right here.
Like, no, like, so she has not
Here's those.
when you
Stable CHC, beta blocker therapy, maximum heart rate is 164. Okay, is there any other?
Put my finger on it.
161.72 age.
yeah,
Did you guys get it?
yeah.
Study about
Addiction is
heart
that
rate and
your
age.
heart rate goes down with age.
Yeah, but you have to give the formula.
Heart rate goes down as you get
It's
older.
over here somewhere. Maybe I'm
I got something here, I got some equations.
yeah, that's it. That's what I was talking about.
That's 2 of them. Where's my third one?
You're so sassy. You're the sassiest person I've ever met right here. Right beside me.
1, 2. Where is my third one? Let's try this. Nope, that's not it. I've got it someplace. Now I just have to remember where that someplace is. Do we have this one yet? Yep, that one we've got.
It's not fun. So I drive all the way back.
Do we have this one? The effects of age and athletic training?
Yeah, we had that.
And Friday.
Okay, here we go. So let's go through them and write them down on our paper. The first one to write down is the one that's given in our book, which says heart rate is 220 minus the age. All right, Menominee, which one did you guys do? Caucasian women? Did you do this one? In healthy Hispanic and Caucasian women? Where did you find your formula?
We didn't get that far.
It's right here. Everybody see it? So we would write for Caucasian women, heart rate Caucasian is 42.77. Oh, that's not the rate. That's oxygen uptake. Sorry. Here it is. Caucasian women is 207 minus 0.62x. Heart rate for Hispanic women is 213.7 minus 0.75x. Who did this one? The effects of age and athletic training. Is that you guys? What did you get? Where did you find your formulas?
Page 374.
374. The heart rate for I forgot what the T was. Are those the ones? Trained subjects. We're going to have to stop there. We'll start there tomorrow. I need your articles back.